Would tell us about yourself and how did you get to Teledyne LeCroy?
Okay. Well, first of all, I've worked here for about 20 years. I came here from Honeywell. I used to work on embedded systems and mostly software. Um, let's see, mostly industrial control type equipment. I came to LeCroy actually sort of by accident. I used LeCroy oscilloscopes in my previous job, but I needed to move from Philadelphia up to here, so looked for a place around here. I will say when I first came on the interview here, I thought oscilloscope design would be pretty boring since it's such an old instrument, but in fact it's probably the most challenging kind of thing you could design, I would say.
So it sounds like you're a very practical person. How much hands-on do you still get in research and development nowadays?
Well, today I'm mostly a manager.
Mm-hmm.
It probably takes about 50% of my time. LeCroy is kind of unusual compared to many companies. Just as a joke, it's sort of a lot of people would rather do technical work than be managers, which is probably not the usual thing you would find in most companies. Most companies, everyone is trying to become a manager.
Right, yeah.
And I don't know if Roger told you anything similar when you talked to him, but I mostly do digital signal processing is really my background, but I also manage the chip development, which is not necessarily my expertise, but I manage that group anyway. I manage a small group of signal processing engineers, and I also manage intellectual property here, like patents and things like that. So, but I spend about 50% of my time doing still digital signal processing type stuff while I'm not keeping an eye on what my group is doing chip development wise.
Very nice. So those green little ASICs that I find in any of the scope I tear down, you're behind that on the management side?
I don't know about the green ones. Oh, you mean, okay, that would be the color of the packages.
Yeah, exactly, the
on,
BGA
right.
package.
Yeah, that's what my group develops. As you're probably aware, and I don't know whether your viewers would be aware of this or not, but an oscilloscope of mostly the really high-end stuff like we make requires custom chip design for just about every chip that goes in it. And that makes us rather unusual because most companies either develop chips and they sell them, and they like to sell a lot of them, or they don't develop chips and they buy them from somebody. But an oscilloscope is such a unique application, and the performance required from it is so high that all three of the companies that make these types of instruments also invest quite a bit in their own chip development. So
I realized that when I opened up the HDO that there's absolutely no way to copy the things because there are proprietary ICs in there that I can't get my hands on. I mean, in the case of the HDO, it's an off-the-shelf analog devices part, but if I remember correctly, you guys were leading the development of that IC with analog devices as well. Yep, and okay, very nice. Now we talked about the HDO, it's a 12-bit scope, wasn't industry's first. Well, LeCroy had one before, but it's a new new industry first. We've seen a higher bandwidth. Again, you broke the barrier again with 100 gigahertz. What's next?
Well, I guess when I graduated school, they were saying Moore's Law was done, and it wasn't, not by a long shot. So, but I will say it's hard for me to get my mind around much higher than 100 gigahertz oscilloscopes, just to be perfectly honest. It'll be one of these statements that will come back to haunt me someday. Like the person who said the worldwide market for computers is 4 or something like that back in the 70s. But I think resolution and accuracy and noise, dynamic range is really the current frontier, I would say. Aside from bandwidth, I think bandwidth is pretty much we've probably gone beyond where most people need right at the moment. But if you look, even if you try to connect oscilloscope, the performance of oscilloscopes with what people are doing in industry, you see that, many years ago, the clock rates on computers were just increasing and increasing at effectively the Moore's law rate, which is, I calculate as doubling every 3 years in speed. But when you look around, let's say early 2000, clock speeds in CPUs have pretty much topped out at 2.5 gigahertz,
Yep.
let's say. And even bus speeds off the chip are hundreds of megahertz still. And but you do see this multi-core paradigm going on, and in some sense, multi-core translated to oscilloscopes would mean, and without clock speeds increasing, would mean less need for more bandwidth, maybe need for more channels, okay, if you have more cores. But when you look at, for example, serial data standards that they've been increasing, but similar in ways that our 100 gigahertz oscilloscope increased. In other words, they've gotten really fast, but there's not a ton of people, I would say, working at the fastest rates. And you see things like multi-level signaling coming along, which has been around for a while, but has probably only recently become something that people really want to do. PAM4 or
Right.
even complex modulation schemes. And those, whenever you go to those types of schemes, rather than going faster, you need better noise performance, better dynamic range, things like that. So to me, that's hence our 12-bit scope. So that I think is the current frontier. Where things are going after that, it's hard for me to say, really. I just worry about building.
All right, that's good. Now, sounds like you've been from hands-on and developed your way here within LeCroy up to where you are now. What would you recommend to somebody that's just an electronics engineering student? What type of soft skills are important if you want to get in with a big player like Teledyne LeCroy?
Okay. If you don't mind, let me answer that two parts.
Okay.
So, because I did think about this when I read the questions before. To me, the skill that has served me the best from a soft skill standpoint has been writing and presenting.
Okay.
I'd say many engineers today are not well suited or equipped to writing and speaking in front of large groups of people. In my case, I have actually worked out a lot of problems just by writing about them. And it's in some sense, when you start to write, you really clarify your thinking a lot better. And when you're done, you have very good, clear ways of communicating things to other people, which is important. And it goes along with presentation skills too, I would say. I've also been in a lot of positions at LeCroy where selling my idea was really, it was part of what made it even possible. In other words, there are many ideas that I've come up with where if I couldn't have sold them, well, then we just wouldn't have done them.
Right.
And therefore you wouldn't have gotten all the benefits for that. So those types of things are often neglected, I think, by engineers, but I even force myself to, I write at least one paper per year and present at a conference once per year. I
Nice.
force myself to do that. And fortunately, LeCroy, the style of the company that it is, if you do that, they'll let you go wherever you want to go if you're going to present papers at conferences. So you can go to some interesting places also and meet some
Very nice.
interesting people. As far as harder skills, I would say, for engineers, through the years, my father was a ham radio guy. That was the thing back in the 40s and 50s. That's how engineers became engineers, by playing with radios. For me, it was computers. I grew up in the age of microprocessors and things like that, and spent my time writing video games and things like that back in the 70s. Today, it's hard for me to figure out what kids do that way to get into engineering. I think there's a lot of opportunities there, but I don't know that kids are necessarily taking advantage of them. And I think schools, I'm also on an advisory board for all of the electrical and computer engineering departments in North America. So with about 25 other people, I try to give them advice on things. And I can see today, schools really have a problem because kids don't have engineering as a hobby per se.
Right.
And as such, the schools are trying to sort of replace that, and they can't, of course, because they have a lot of other things to teach. And so it's sort of a very difficult situation. And kids come here on interviews, and they really have no experience whatsoever, I would say, doing just about anything unless they did something as a hobby. So I would encourage kids who want to get into engineering to really try to do some outside of school work, playing around with things and building things or what have you.
I've noticed that here in the United States in particular, in Europe it's not so much. People have a little bit of more practical experience, simply the way the colleges are set up. We're trying to be more practical. But over here, somebody can break down a complex problem mathematically, theoretically, very easily. And if you ask them about a practical application, they're lost. And it seems like they build that experience on the beginning of their career, and somebody basically pays for training somebody in that time. That's what it appears like sometimes. I guess it goes along the lines of what you said.
Yeah.
All right. Now, what do you think would be the most overlooked or misunderstood attribute of an oscilloscope?
I have to be really careful on camera answering something like this, but I would have to say, from my experience, there's two things that I can point to there. One is the inaccuracy of the device itself. I've had, throughout my 20 years working on oscilloscopes, I've had people wondering why they don't get, 6-digit accuracy in like a voltmeter measurement on an oscilloscope. And oscilloscopes, while they are very, very precise instruments and have also become much more precise over time, even if you just keep in mind the flatness of an oscilloscope might be plus or minus a dB or so, but a dB is 10% of your signal. So you're going to have a plus or minus 10% accuracy level in measuring, let's say, the amplitude of a sine wave at a given frequency. And when you really think about that, 10% is a pretty big error.
Yep, that's a lot.
So there's, I would say there's that aspect, not understanding the accuracy of the instrument itself. The other thing is probing, I would say. When you, especially at high frequencies, when you put a probe on a circuit, you are introducing a new circuit element into your circuit. And many times the probe, even just the capacitance, the probe tip can stop the circuit from functioning. Sometimes it helps the circuit, actually.
Yes, I've seen that before in applications.
Exactly.
Yeah.
And I've seen probably I've seen a lot of instances where customers were measuring something, not liking the measurement results, and when you looked over where the probe was, you saw like a giant wire tacked on with no ground clip or things like that. And so that probing for sure is one of the most ill understood.
That brings up some
topics.
childhood memories of me when I started building oscillators for amateur radio sets, and I would just stick the probe into an unbuffered stage, and it would completely screw up the circuit.
Exactly.
And at that age, I had no idea what it was. I mean, I was barely in high school, so.
Yeah.
But yeah, very important. So, if a hobbyist would want to buy their first oscilloscope, their very first oscilloscope, what would be that one recommendation that you would give them as far as what to watch out for?
What to watch out for your first oscilloscope. So, because I have to try to translate that question. I would assume that would be a relatively inexpensive oscilloscope.
Probably, yes, exactly. What do I not want to save on?
I don't know. It's hard. It's very hard.
It's
for me
tough,
to
isn't
say,
it? Yeah.
you know. It's because since I know what I'm doing with an oscilloscope, I probably don't really worry that much about it. I guess sample rate. Want to make sure you have enough sample rate, because that can really confuse you when you don't have enough
Yeah.
sample rate. But I don't know. Just buy a LeCroy oscilloscope. You'll be good.
Very nice. Maybe start out with a wave ace, yeah. Or a wave set for 3,000. That works too.
That would be my
That-
preference.
That would be your preference, yeah, mine too. I reviewed it somewhere on the blog before. It's a really nice oscilloscope.
Yes.
All right, Pete, that's all the questions I have.
Okay.
So thanks for
All
talking
right.
to us.
All right.
And that's it.